All right, we're going to look at volume of a sphere. You already know the formula from a previous video. Remember that 4/3 is because that sphere is bigger than the cone and the cylinder that may have the same radius, and the height in this case is the radius on top of itself. So let's try a couple of examples. Mrs. Wheeler had a delicious orange as a snack yesterday. It had a diameter of 12 centimeters. What is its volume? So we know that an orange, if it were perfect, would be the shape of a sphere. So that'll be 4/3 pi r cubed. And we are going to substitute in for that. If you're using your calculator for the 4/3, you can type it in as 4 divided by 3. Pi will be 3.14. And then if the diameter is 12, then the radius must be, hopefully you were thinking 6 centimeters. We divide that diameter in half. And so 6 to the third power would be 6 times 6 times 6. Just be careful you're not calculating 6 times 3. I like to write out all of them. And then type it into your calculator carefully. I got 904 and 3/10 about. I rounded it off. You could also cube your 6 first and make that 216 and multiply it in that way. That gives you a bit fewer numbers to type in, and you should get the same solution. And this is centimeters times centimeters times centimeters, so centimeters cubed. Hooray! Let's move on to the next example. All right, we've got a globe with an 8-inch radius, and we're being asked to find volume. So I'm going to start with that formula, 4/3 pi r cubed, and typing that in as 4 divided by 3. Pi will be 3.14, and radius for radius cubed. It's kind of nice when they give you the radius. You don't have to do any extra calculations. And I'm just multiplying it out. 2,143 and about 0.6. I think it says 0.57 or 57 hundredths, rounds up to 6/10. And I'm going to double check my work just like you should. Yep, and my answer was confirmed. My units here should be inches to the third power. Volume is cubed. Hopefully you're doing all right. This one's a little bit more challenging. It didn't give me a diagram, so I'm going to go ahead and draw a sphere. I just kind of draw a circle with a circle going through its center. Sometimes that's a dashed line, and it has a 3-inch diameter. So I'm going to find the volume of that tennis ball. And I'm going to change that diameter, divide that by 2 to get my radius of 1.5 inches. So just make sure you're careful when it says diameter to convert that. And there's a couple of different ways you can write your solutions. Sometimes people will, sometimes the answer choices on a multiple choice test might have pi in the answer instead of 3.14 or 3 14 hundredths. So just be careful. You can always evaluate that by changing the pi to 3.14. And this would definitely be one you want to type in at least twice, because there are quite a bit of decimals there. I just typed way too many buttons into my calculator. Yeah, and I did get the same thing, inches cubed. And then we have a follow-up question that goes with this tennis ball one. It says, how many of these tennis balls will fit in a cylinder can? It should have said cylindrical. So I'm going to kind of sketch that out here. We've got this can, And we're basically asking how many of these tennis balls are going to fit inside the can. It has a 4-inch diameter and a height of 12 inches. So I like to sketch the diagram if it's not given for you. Got to throw back to the volume of a cylinder. So first I'm going to figure out how big this cylinder is. That's the area of the base circle, pi r squared, times the height of the cylinder. And if the diameter is 12, the radius is 2. I'm going to multiply it times itself to square it. And the height is 12. So my cylindrical can has a volume of 150 and 72 hundredths inches cubed. I'm going to double check that to make sure I typed it in correctly. Seems reasonable. Now, if that's the whole cylinder, and I know each tennis ball is this big, 14 inches cubed, I want to figure out how many of these will fit inside. Well, you're asking yourself how many tennis balls go into one can, and that phrase, how many go into one, is going to remind us this is a division problem. So we can take the volume of the whole can and divide it by 14.1. Not sure why I wrote it like that. I'm not planning to do long division. I am going to use my calculator. So and when we get that, we get about 10.68. So these must be, that seems about right. You could double check it, but 150 divided by 14 is about 10. And we would say that would be 10 whole tennis balls, right? This kind of extra part might be the space around them that doesn't fit in. All right, so that is about it for today. Have a good one.